everyone, and welcome to another episode of the EFRA podcast series. I'm Urania Dinu from Reino, the partner responsible for EFRA's impact and outreach. EFRA is an EU-funded research project that aims to transform food safety, shifting from reaction to prevention. Using cutting-edge data analytics and AI, EFRA gathers and processes diverse data in order to make predictions related to food safety risks before they happen, enabling smarter and faster responses across the food supply chain. In today's episode, we are honored to welcome Korbinian Randl, PhD student at the Stockholm University. And we will have a very insightful discussion on one of the EFRA's results, but also platform's components, the Data Hub. So, hello Korbinian, and thank you for joining us.
Hi, happy to be here.
Let's set the scene for our listeners. Can you briefly introduce your organization, but also your role in the EFRA project?
Sure. Stockholm University's team is like Aron Henriksson, Tony Lindgren, and me from the Department of Computer and System Sciences at Stockholm. We also have one external member, John Pavlopoulos, who is currently working at Athens University of Economics and Business, but he's affiliated with our team. Our role in the project is mostly creating NLP, so language understanding tools for the project. So basically working on text data from the internet mostly. But we're also leading EFRA's efforts in the Data Hub, as you just said.
So what is meant by a Data Hub in the context of EFRA, and why is it important for food risk prediction?
The Data Hub for EFRA is a central piece of infrastructure that stores data, like various kinds of data that we use for our prediction efforts. And it's basically maintained and built by Maze, our partner. It does not only store data. The idea is we have a server that stores the data and that also can enrich the data, for example, by translating it to other languages or by extracting important pointers that we can then later on use for like other machine learning tasks. Also, we have crawlers in this Data Hub, meaning that is some kind of software that collects data from the internet.
Now that you said crawlers, and I can imagine that is a key feature of the Data Hub. Could you tell us a bit more about what a crawler is and what it does?
So a crawler is a piece of software, again, that intelligently searches the internet for important information depending on your use case. In our case, the crawler starts at specific websites that we know are important for food safety, for example, the European Food Safety Authority, and then it follows links on these web pages and decides using machine learning models and other AI tools whether the content is important for our task or not, and if it is important, it's downloading that.
So what kind of data are you working with? If you can give us some examples of sources or types of data.
As I said before, we as Stockholm University are mostly working with text data. That is, for example, food recall announcements from the FDA in the US or the European Food Safety Authority. And these are announcements by these authorities that for example, tell us not to consume a specific food product because there may be salmonella, or we know that there's salmonella in this product, or that the packaging machine was broken and we have metal particles, for example. There's also other types of textual data that we have, like food legislation texts or social media texts, but we also deal in other non-textual data. for example, weather data that can be useful for farmers to see or to prevent food risks, pests. For example, mold there's a high risk for mold if it's wet weather. And we also have other data on food pests, both for plants and for livestock.
So we see that we have a rich and diverse data landscape. Can external data providers connect to the EFRA data ecosystem, and how?
Right now, we are in the production phase of the ecosystem, so you're not able to connect to it right now. But we are definitely planning that to be the case in the future, so that people can connect to it. At the current speed of development, I would expect that to be in the end of the year. We already have the API, so the programming interface that people can connect with, up and running, but it's for now reserved for internal testing.
Now let's go back to data mining. Can you briefly explain what this term means?
So data mining means extraction of important information from data, or like that's the most general term. Usually you use machine learning techniques for that, and in our specific case this is important because it brings speed to the whole process. So compared to a traditional process where a human operator would search the internet for information, extract important things, and then act on that, we can be faster here because we have the crawlers that we talked about before, but then also machine learning models that mine the data for important information and process that at higher speed.
You mentioned machine learning also before. Could you tell us more about what is it and how it is used in EFRA?
Machine learning is again software, so most of the stuff that we do here is software. But software that is not like traditionally programmed by a human person, and then the human person defines all the details of this program, but more it's a kind of software that goes through lots of data and then automatically or statistically learns learns to find important information in these points.
Mm-hmm.
So a useful example, or an example that is often used, is spam filters. Because every person has a different idea about what a spam email is, and basically by clicking in your email program, this is spam and this is not spam, the program will automatically learn if there's specific words in an email, then it's most likely to be regarded as spam by the user or not. So it's statistically evaluating each thing based on the input of the user.
Mm-hmm. So. Very interesting. I think also ChatGPT uses machine learning. So we see that machine learning is broadly applied. Now looking ahead, how do you see data mining methods that you follow in EFRA transforming food safety maybe in 5-10 years?
So the thing is, it's hard to see the future. I hope that EFRA doesn't make an impact on food safety, or at least the processing of food safety information in a digital way. But the information technology industry or sector moves very fastly. If you think back 10 years, Google Translate, which was available but then was still a rule-based system, meaning that it translated the text, but you could see grammatical errors in there. Nowadays, it's completely transformed to being a neural or machine learning based system, and we can see, we can basically translate any language to any language fluently, and you couldn't see if that was done by a human or a computer. Mm-hmm. So there's huge improvements. There's very fast pace, so it's hard to say what will happen in 10 years.
So thank you, Korbinian, for sharing all this insight regarding data mining and how we do data mining in EFRA. We really hope to see how EFRA will change and improve food safety across Europe.
Thank you.
Also, thank you all for being with us today in another episode of the EFRA podcast series. Stay tuned for our next episodes where we will explore more modules of the EFRA platform, but also we will explore more aspects of the project. Don't forget to follow us on social media and visit our website for more insights on AI and food safety. Let's make our food safer together. Stay tuned.